We are now at Oral 5. This is Brookhaven, Mississippi. It's a Mission 5 flight experiment.
Good morning. Our group is from Brookhaven, Mississippi, and we recently graduated from Brookhaven Academy. Next slide. Our project is titled Polyhydroxyalkanoate Production and Microgravity, and we'll be on Flight Experiment Mission 5 to the International Space Station. Next slide. My name is Garrett Smith, and these are my co-investigators who will introduce themselves.
I'm Lindsay Winburn.
I'm Ruth Vaughn. And I'm Ashley Bardwell.
Samantha Barton, who contributed a lot to this project, cannot be here today. Next slide. Our teachers that helped us are Dr. Diane Watson and Miss Leslie Hood. Next slide. Before we get started, I would like to thank the Selby and Richard McRae Foundation, the Energy Foundation, the Mississippi Space Consortium, Brookhaven Academy Educational Foundation, and Dr. Donna Sullivan from UMC. Next slide. The purpose of this experiment is to determine whether or not Ralstonia eutrophium will create polyhydroxyalkanoates, also known as PHA, after being exposed to microgravity for 3 weeks. PHA is a biodegradable polyester created by bacterial fermentation. Next slide. We chose Ralstonia eutrophium as our bacteria to make PHA because our group had checked previous studies and realized that it was the best bacteria and easiest to use to make PHA. Next slide. For our materials, we used Ralstonia eutrophium, phosphate buffered saline, a brain heart infusion broth, RNA later 3, and used the type 3 FME. Next slide. The growth of SPY1 in production medium is monitored by taking absorbance at 660 nanometers, and the corresponding amount of PHA accumulated was determined by incubating it for 5 days. The stock cultures were revived in the nutrient broth and later inoculated into mineral salts medium. pH was adjusted to 7.4 plus or minus 5.05, and the cultures were incubated for 48 hours at 30 degrees Celsius in the orbital shaker. Next slide. After the incubation, we centrifuged the cultures for 5 minutes at 10,000 revolutions per minute. We discarded the supernatant, leaving only the pellet. The cell pellet was suspended in a sodium hypochlorite solution in order to remove all of the cell components except for the PHA. The pellets were then centrifuged and washed in distilled water. Next slide. The PHA granules were identified by transmission electron microscopy, and then the bacterial cultures were centrifuged again at 10,000 RPM for 5 minutes. We used transmission electron microscopy because it yielded the best results when dealing with PHA according to previous studies. We then separated the Ralstonia eutrophium, the brain heart infusion broth, and the RNA later 2 into their appropriate compartments. Next slide. The experiment will be tested on the International Space Station. The results will be sent to us at the University of Mississippi Medical Center, where we will again perform transmission electron microscopy and compare the amount of PHA production to the amount here tested on Earth later. Next slide. Our hypothesis is that more PHA granules will be produced in microgravity than on Earth. The experiment will prove or falsify the idea that the bacteria Ralstonia eutrophium can produce PHA in microgravity. If the bacteria can make PHA after being exposed to microgravity, it will allow for several medical components to be made in space, such as anti-cancer drugs, vein valve replacements, skin grafts, and several other things that in the medical field. Next slide. On behalf of the team, I would like to thank SSEP for this amazing opportunity. We are very honored to represent the great state of Mississippi in our school, Brookhaven Academy, and to be the first team from Mississippi to be a part of this great program. Thank you for your time. Any questions?
Questions for Brookhaven, Mississippi?
Tim from Goddard Space Flight Center. Is PHA suitable for use in a 3D printer?
I really don't know, but it's very testable, so I guess we could test it. But it doesn't really, it is used to make plastic, but it's not actually plastic itself. So okay. I don't know.
Okay, thank you.
Okay, let's thank Brookhaven, Mississippi.